Okay, so the problem says to divide the grid shown to the right into more than one region so that the following rules are satisfied. 1. Each unit square lies entirely within exactly one region. 2. Each region is a single piece connected by the edges of its unit squares. 3. Each region contains the same number of whole unit squares. And 4. Each region contains the same sum of numbers. Okay. So, let's see. This is a 7 by 8 grid. So that's 56 unit squares. And the sum of all these numbers is 17, 10, 10, 4, 7, 12, and 3 as a sum of 63. So we need to divide this grid into pieces so that there's the same number of squares and the same sum of numbers within each piece. So that means that each piece has to be divisible, or yeah, the number of unit squares in each piece has to divide 56, and the number of pieces, or the sum of the numbers in each piece has to divide 63. So the only common factor that they share besides 1 is 9. So that gives us, we want 9 to be the number of square, 9 to be, what am I saying? It's supposed to be 8. Okay, I'm 7. Yeah, 7's the only number that divides these two. So yeah, 7. So 7 should be the number of squares in each piece, and 7 should be the sum within each piece. I don't know. 7. Okay, yeah. 7 is the number of pieces there should be, so there should be 8 squares. And because there are 8 squares, we want a 9, the sum of 9. Yes, so 7 pieces with sum of 9 and 8 squares within each piece. Okay. So we know that we want all the pieces to have a sum of 9. So immediately here we have a problem because we can't have 6, 5, and 6 sharing any, or we can't have any of these in the same piece because it would exceed 9 automatically. So we want to pair this 6 with 3 because that's the only other number that could add to 9 within range. So we want to connect 6 with 3 for sure. And that gives us 1, 2, 3, 4, 5, 6 pieces, so we have room for 2 more. Could be over here. So bottom line, we know we want to connect these two. And so that leaves 5 and 4 here have to be connected. And we need 6 blank squares to complete this piece. So that lets us go 1, 2, 3, 4, 5, 6, 7. Yeah, that would work. And we know that, so we have a 4 here and a 1 here and another 4. So 4 plus 4 plus 1 would equal 9. We want to connect these. So if we connected 1, 2, 3, 4, 5, 6, 7, 8, that's the only full piece we know for sure. Because it's the maximum length it could be. There we go. That's one piece. So we want to fill in these spots. So we want to connect the 6 3-piece here to give us a full 8 squares. So that's another piece. Maybe that's hard to see. I'm trying using a different color. Try yellow. There we go. And also the 4, 4, and 1. Okay. So if we look at 1s and 4s here, we know that we could connect the 1 and 1 together, but given that there's a lot of even numbers in here, we want to make sure that the odds and evens are sort of spread out so that we make sure that we have a sum of 9, which is an odd number. So we want the same thing. We want another 441 and a 441. So we have, so 1 and 4 has to it has to connect to this one since this 4 can't possibly reach this one. Yes. So it's 1, 2, 3, 4, 5, 6 spots. This one has to connect with this one, or this 4. So the only 4 that this piece could possibly reach is this one. So we have another full piece. That's 8 pieces, okay. And so the only direction this piece could go in is to this 4 as well. So it's 1, 2, 3, 4, 5, 6, 7 pieces. You can fit in one more somewhere. Oh, it's complete. I know, you can't tell which one it's going to be. So, yes, going back to, so what can we do with this 3? We could do 3 to 4, but if we connected these 3 pieces, then we wouldn't be able to connect this 6 with this 3. So we want to connect this 3 with this 6, so that we get 9 all around. And we would have to include this corner piece, because that's the only place it can go now. So that is 1, 2, 3, 4, 5, 6, 7, 8 pieces. Perfect. That's another piece. Yes. So let's finish this one up. So we have 1, 2, and we need 6 more squares. So we can put, yes, the only squares that are available, the only blank squares that are available to this one are this one, this one, this one, and this one. We can't have this piece cover this blank square because then the 4 wouldn't have any place to go. So we want to connect this way. That is 1, 2, 3, 4, 5, 6, 7, 8. That's 8 whole pieces. That's 8 squares for this piece to have. So that leaves, because this 4 has to connect to this 3 and 2 to make the final piece, this other piece can't extend this way, it can only extend this way. So here we have kind of a square. And that would be 8 pieces here too. And that just leaves 1, 2, 3, 4, 5, 6, 7, 8 of the final piece with a sum of 9 in it. Yay! That is the solution.